being asked to find out, well, prove that this particular graph, x cubed minus 5, has a root, so that's crossing the y-axis between x is 1 and x is 2. So let's draw a picture of what's going on here. We've got the graph of x cubed minus 5, which looks like this. There's minus 5 down there, and apparently there's this root here, and it's allegedly between 1 and 2. So we've got x is 1, x is 2. I'm not drawing this to scale at all, but you get the idea. X is 1 and x is 2, and apparently the root's in between. So the way that we're going to prove this is to use a sign change argument. What we're going to do is we're going to say, well, at x is 1, the graph is negative. So don't really know what's happening in between 1 and 2, but at 1 it's negative, and then at 2 it's positive. So, logically, if it's going to get from negative to positive, then it must somehow cross over the y-axis, unless it's not continuous. But this is, if it has a jump, basically, if it jumps over the y-axis. But x cubed is a continuous graph. You draw it without taking your pen off the page. So it must somehow cross over. So that's the idea of the sign change argument. Show that it goes from negative to positive, and then argue that it must therefore somewhere cross over the y-axis. Okay, so let's try that. So what's happening at 1? When x is 1, well, 1 cubed minus 5 is minus 4, that's negative. At x is 2, well, 2 cubed minus 5 is 3, that's positive. So we've done it. We've got a sign change. And therefore, there is a root between, and this is what you have to write for the exam, there is a sign change, therefore is a root between x is 1 and x is 2. So somewhere between there and there's a root. Easy, right? Slightly different style of problem now. We're looking for where two graphs intersect. So let's just draw a little picture, see what's going on. We've got the graph of e to the x minus 7. So that's got an asymptote at minus 7. And it goes up quite slowly, and then it gets steeper and steeper and steeper and steeper and steeper and steeper, like this. And then we've got another graph, x squared, which is quite shallow really. Does this, and then goes off. I'm not drawing it brilliantly, but get the idea. E to the x minus 7. So, there it is. Dun, dun, that's the intersection point. And according to this question, the intersection point is somewhere between 2.6 and 2.7. So how are we going to prove that? Well, I'd like to use the same argument that I just used, the sign change argument, but nothing's changing sign between 2.6 and 2.7. Nothing's going from positive to negative. So what I'm going to do is rephrase the question in a way that allows me to use my sign change argument. So what's the question saying at the moment? It's saying that we need a solution to the equation squared equals e to the x minus 7, and it's saying that that has a solution between x is 2.6 and x is 2.7. Somewhere between those two. So let's just rephrase it. If x squared equals e to the x minus 7, somewhere between those two, then x squared minus e to the x plus 7 would equal 0 between x is 2.6 and x is 2.7. It's the same question. So that means I've now turned it into the question I had a minute ago, where I was looking for a root, and I'm looking for a root of this now, so I can use my sign change argument. So let's see what's going on at 2.6. At x is 2.6. Got 2.6 squared minus e to the 2.6 plus 7, and that comes out to be 0.296. And then at x is 2.7, well, 2.7 squared minus e to the 2.7 plus 7 comes out to be minus 0.590. Just as a note for the exam, you will need at least 3 significant figures here, so I think it's safer to do a load more, to be honest, just in case. So go for 3 minimum. Definitely don't only do 2, but I think do 4 or 5 just to be sure that you're going to get that accuracy mark. So what have we got? We've got a sign change. Hooray. What does that mean? The sign change now means that this function here, e to the x squared minus e to the x plus 7, has a root. But that wasn't actually what I was asked to find. I was asked to find an intersection point. So the sign change means that x squared crosses, or intersects, e to the x minus 7 between 2.6 and 2.7. So it's important to go back to your original question when you're concluding. What we wanted to find was that where x squared intersects e to the x minus 7, and we've managed to use a sign change argument to do that by rephrasing the question into something that equals naught. That's the key. The sign change argument works because we're seeing comparing something to equaling naught. So if we need to, we rephrase the question. Last example, we are looking for a turning point now. So this graph looks like this. It's quite a nice graph. And it's got a turning point, allegedly, between 1.5 and 2.5. And we're going to try to prove that that is indeed the case using a sign change argument. So what is it that's going to equal 0? We need something to equal 0. Obviously, it is, for a turning point, the derivative. So what's dy by dx? dy by dx is, we've got product rule here, hold the x still while we differentiate the sine x, then plus, then hold the sine x still while we differentiate the x, and then that's the derivative. And we want a turning point, so we want that to equal naught. So what we're actually saying is, has this function got a root between 1.5 and 2.5? That's what we're actually asking. So let's use our sign change argument to see. So at x is 1.5. 1.5 cos 1.5, making sure our calculator is in radians, plus sine 1.5 is 1.104. At x is 2.5, we get 2.5 cosine 2.5 plus sine of 2.5, and that comes out to be minus 1.404. Good, we have a sign change. So there's our sign change. Now what can we conclude? Sign change, therefore what? So the sign change tells us that this function, x cos x plus sine x, has a root between 1.5 and 2.5, but that wasn't what we were actually asked. We were asked where this function has a turning point. So what we can conclude is, therefore, x sine x has a turning point between x is 1.5 and x is 2.5. Reminder again that I did these to 3 significant figures. That's the absolute bare minimum. I'd recommend doing 4 or 5.